Ủa? Cái này nó bị mất một số slide ở đây. Ok. Ok, mình cứ bắt đầu luôn. Ok, chào mọi người. Thì hôm nay em sẽ rất vui trình bày với mọi người. Lâu lên. Dạ. Okay. Hi everyone. Today I'm so delighted to continue our reading group session, and I will present to you the paper named Large Language Model, a Competitive Near Close Start Recommender System for Large and Item-Based Preference. Okay, the outline of my presentation including 5 sessions. Session 1, I will introduce the application of large language model on recommendation. And in this paper, they have a special data for their experiments. So I will introduce a protocol to collect data on their paper. And after that, I will present some way to fine-tune to tune the large language model to implement the recommendation task on large language model. And I will introduce some results obtained via that paper, and finally I will conclude some contribution of the author in this paper. As we know, in the conventional recommender system, we often use metric factorization, which is decompose the interacted metric into low rank metric. It is a item feature metric and user metric, and we will use the the product of these metric, the item metric and user metric, to approximate the utility metric. And we will have some predicted rating or predicted probability of the user will interact with uninteracted item. And now in the development of large scale model, especially large language model, a question is that how whether we can use a large language model in our recommender system task. For example, if we have some input like we purchased a user one file. Okay. Yes. If we have some inputs in natural language like user 15466 have some history list structure like that, and we will ask the model what is next items should be recommended to the user. We ask the large language model that's what star rating of what star rating do you think user ABC will be to item exists, something like that, and we will have some response from large language model. That's the next item that user will interact or interest in the item have some ID section like this, and the rating of user for a special item is 5.0. Yes, so that's some way we can apply large language model in recommender system. That we input a natural language, and output is some response from the large language model about the next item directing or some comment the an user will give for an interactive item. And yes, as we know that large language model have input in a sequence, a natural sequence, and it will be encoded in embedding vectors. So, and it's therefore in large language model we have a dictionary of embedding metric. Thus we map word in human language to an embedding vector, and therefore output of our large language model is a sequence of embedding vectors, and output also is the response of large language model, and is also some embedding vector, correct? Such as if we is a number, if we do it as a regression task for rating prediction. And in our recommended system, do you have turn off the video? Turn off video effect. Okay. Blur. It's blur. Actually, I turn off it. Check it. Apply. Apply. Okay. Thank you. Yes, and in our special case, we have some space to describe our preference in a natural language, which is input of the large language model. We not only use some available tokens or available embedding vectors in embedding metric of the large language model. We must have some special tokens in the large language model to represent an user or an item. For example, in this case, we have some natural language. What rating do you think is the natural language which is the variable was in embedding in the pre-trained model? But user 23 or item 7391 is not available in embedding metric. So we must create some additional token representing for user or items. And in this case, the research question the authors want to answer after their paper is asked how effective of natural language in near constant recommendation. Yes, and how do we just for more analysis or more discussion in this question? We know that when some user is new in our system, we don't have or have a very little data about this new user, and it's very difficult to suggest a new item for that user. And in this case, if we utilize the huge data trained from pre-trained model or large language model, it can more effective to suggest new item for a new user in near constant setting. Furthermore, other question we want to answer is that how do large language model based recommended system methods compare with conventional methods like item-based collaborative filtering. And after that, we want to find what is the best way to fine-tune the large language model to our recommended system. And finally, we will answer that can we can natural language combined with item or collaborative filtering can improve the performance of recommended system task. And in this paper, they have a special data to their special experiments. In this case, they propose a protocol to collect data from user. And in phase one, they will collect the natural language about preference of a user, about the movie user like or dislike. For example, each creator will be asked about some will be asked to describe about the movie they like or dislike. For example, in this case, the user one like comedy movies, so his or hers, he or she will describe that they like comedy movies because they feel happy when watch them, etc. Or they dislike horror movies because they feel alone and disturbed with the character in the movie. Yeah.
So it's mean that they collect the like comments of the user with these movies and other movies. It's not the same, but it's not in the same category of the movies.
Yes, they only describe about genre of a movie.
Yes. However, sometimes there's not many people comments their ideas on writing movies. So, I mean, as they just collect on user have comments on the like movie and dislike, or just this user just comments on the movie they like with without the dislike.
Example, in this way, the random one gives you both to
It's mean that we have to find a user that have both comments on two type of movie.
Yes, they actually in this paper they ask every writer describe about both type of like and dislike movies. And this describe is also talk about the general preference like genre or
Maybe it's tough for the participant. They have to watch if they're task for joining the high process.
Yes, they as I remember they asked about 150 people attend to this case to collect this data. Yes, you have any question? Other question? I will continue my presentation. Yes, and after giving some movie preferences, illustrator must choose 5 liked items. Is noted by item RJ plus, and also choose 5 disliked item denoted by item RJ minus. And actually, after that, they must provide feedback about these 10 items, about how they like that movie and how they dislike this movie. Yes, it's very complicated.
There are like 1,500 comments.
Yes.
The 150 participants.
Yes,
So we have 100.
150, 1,500 comments. Yes, and in space two, they will, mm, they require user rate for 40 movies sample from for set data. Yes, it really quite small because the movie pool is only for 40 movies.
Oh.
And actually they choose is from four kind of data source. I think it's not too important, and generally they only in this paper they only work with these 40 movies. So we only need that they ask all narrator to rate 40 movies, rate for 40 movie in scale of 1 to 5.
Of same movie, it means that the user had already seen that movie.
Yes. And in this case, the unseen movie very. Mm,
I have to give it that because you have.
It was the enough beautiful. I give it 1 star.
Because I haven't seen, so how could I rate it?
Yeah.
I don't know. Maybe they mostly this the old movie, and after that they will be asked for rating.
Sure, they just be the Tamil movies.
Teaser or trailer.
Maybe in the start they will be asked about seen movie and unseen movie, and after that they will be asked for rating these 40 movies. Yes. Okay. How many movie seen or unseen? Mm, this is the fraction scene. Fraction scene in this case. Yeah.
It means that in the single pool run top, you have 10 movie and most people only watch about 2 of them. Or what?
Yes. Actually, we see 22% of this movie of this pool is seen by readers. In average, in this 10 movie, at least each reader seen at least 2 movie.
At least on average.
In average, yeah, in average. Okay. Yes, and after that, I will suggest new item for this 40 movie. And in this session, I will present the way to fine-tune the national week model in our recommended system task. They have three kind of setting in this case, and in the first case, they use setting. The setting is that we use only the information or data about items. That, for example, we know that user user T, a special user, like 5 item T1, item T2, and to item T5. And after that, they will have some rating on this movie T stars. And so the input of The input of large language model in this case is that the five special tokens about this defined item, and after that the output is the rating of 40 movies that the user will like, we will predict it, we will rate for these 40 items. Or in in this case, their sort their sort item that they will when we transfer the fine tune program into the sort learning, that we have 5 positive items, and after that we have output a natural response, and thus then the I will which also like item ABC. In this case, the rating will be split into two kinds. If the that's positive, that user like this item or dislike this item by the rating for 40 movie. If it's greater than or equal 3, it will be positive item, and after that, positive item by versa. And in the third setting is if you start learning, that we will uh, that we will use the movie preference. We use the movie preference, that item R1 to item R4, and we will add some additional preference at item preference item 5. It's like that we have five. We have some. Actually we have 4 available movie preference, and now we have some coming or upcoming additional movie preference 5, and we will our large language model will respond the rating or the preference about the on arbitrary item in the 40 movie pool. We need to predict it.
So what is the difference between these three tasks? Because I can summarize that as I give you some item I prefer. So what is the next item I want to see next, right?
Yes, it's the general purpose, and but in this case we have some different input and output. Actually different input. For example, in this case we only give the large language model the 5 special token.
Yes.
And but in this case, we will ask it like some we ask some natural language tokens, and the output of the model is then the user will also like item this item.
I think there are three completion and zero sort and full sort three kind of input for LLMs, right?
Yes.
And the first one completion, you only place the item without any explanation. Like I like the following movie. It's like the explanation and the language in the nature that is different between completion and zero sum. So they want to test what different input you put through the LMs and the performance we get. What is different?
Yes. And in this case, the output is also different between the different setting or different styles. When in this case, the output is also a special token or some special token representing for the item needs to predict it.
Short and future.
It also gives us some special token, but it will with some additional natural language. Add some natural tokens for human language.
But I can also see that I should use a movie preference at the direction for the LM model.
Sorry, what do you say?
Mean the both zero shot and field shot has some direction about what we should find. For example, like the following, or maybe I would like, and we also have some direction in the field shot, like reference or additional reference for the next item. So what is the difference between the zero shot and field shot? Maybe about the kind.
In this case, the input of actually in field shot we have some repeat, some loop, or in this case when we not use on the fun, we in this case we use the preference of item. For example, in this case the preference movie preference is natural. That would be a sentence describe about what user like in that item. The item one, the description on how user like item two, and in this case, if we have for preferences, and we have a new preferences from this. We have a new preference. It's a preference file. It's a description about how user like item file. We will predict some preference for an arbitrary in the pool of 40 movies.
So you mean the zero shot, the item will give you like some code of the item on the system, right? But for the field shot, the item here will be the description of each user for the preferred item in the
Actually in this case output is user preferences from 1 to 4, and output is additional user movie preference 5. And after that, we read for item 1. We have inputs R is description from 2 to 5, and we predicted the preference, user preference for item 1.
You need to split in zero shot we have 1 to 5, in two shot we have 1 to 4, and then we have additional item 5. So why do we need to have that separation? I still don't care.
I think the question is the repeat is mean that in zero shot you will give the description about both five items and you bring someone else, but for the input for the field shot you will like repeat and rotationary.
Yes,
For example, you have five.
you have 4 items to predict the other one.
Yes,
Okay.
you just like it's more like a K folder or something.
The key point, I think it is like they want to emphasize in the last item, right?
Okay.
Because the structure, as I mentioned before, the structure for the input for LLMs different, and they want to find what is impact on the
Last item. Yeah.
structure.
Yeah, that's right. The shots mean you will give them some example. For example, like the how you just gave one question and ask the model to release the sentence. But if you starting with this some example like those sentences. With okay example, ask the model to complete the remaining question.
So
It's a field of vision. It just a function, for example.
Can give any example that makes sense.
But it could be like for the two user.
Yes, you can give it use to user.
It's not clear here. It's
Just yeah, not all those and us is meaning of T and R. You see,
TT.
Whereas we want to kind of what is kind
what is K?
yes.
Okay.
I forgot it. Especially I
It's actually on. Hello, hello.
We have maybe pre-structure for the
Yeah.
input of LLM. So we discuss more about the next one.
Yes. And in this case, we will have some description. We only use the description only to fine tune the large language model. In this case, if we have some description about some positive item that a user like, we will predict some movie. Based on that, we predict the movie that user like in the pool for the movie. And in this case, in the source, we have the same item in the same item only setting that we will provide description about kind of movie that a user like, and after that we predict it is in the same way of item only setting, and few sources also something like this that we have some description about general preference, and after that we provide some movie preferences. And yes, and finally in this setting we will both item and language description in our input. That, for example, in comparison, we provide description about the general kind of movie that user will like, and we provide more additional. We will provide 5 special token about that like item of an arbitrary user, and we predicted some potential movies that user will like.
In the input must belong to the same category in the description. Only I said that I like horror movie, but in the item I like maybe contain some like I don't know, comedies, something like that.
Actually, I don't think description must specific about a genre. For example, they only describe that I like some happy movie, some funny movie, and some interesting movie have a long time or a long uh, a long length, and they will provide 5 items that they like, and therefore these 5 items not necessarily belong to a kind of genre.
Also, so the description is also about genre movie, just like the hobby of
Yeah.
what they like, right?
Yes. And this yes, the special way, special thing in this case that we will use both language and item in input and output, and therefore I expect that this testing is more competitive and has highest performance because the data resource of this testing is more rich.
I think here is the ideal people.
Sorry,
RNT,
RNT.
denote user ID.
I think it's a user ID.
User. I'm not sure.
And it will send you
As a user ID, it gives me that user like the 4 item, and there should additional one they want to predict against the item 5 list, and then a question about them. Their hobbies, maybe about the description are positive. So the repeat want to claim means maybe the number of user they use to produce a training data set.
I can yes.
Or maybe the same data set. But it will make more sense.
Let me see. The next question again. I'm not sure they will specify the letter ID or user ID in this denotation. Yes, R stand for letter, and T, I'm not sure T stand for what. Yes.
T is for target.
Target.
R for resource.
We should dig into this.
And yeah, on the page 5, they mention the item for target user is denoted as item T. So I think
Okay, so T
yeah, it is
some user, some user, sometimes user.
Oh, so it's
here. It's here. Because T is specific target rated
Mm.
and R denote for generic rated.
Generic letter.
It's mean it's generate from the element. And the target is it from element to satisfy.
I'm not sure.
Oh, yeah.
And we open it.
Just
From
yeah.
Yeah.
But they should use like the acronym table for refer some like
T should stand for user ID. Because in the form you repeat it, I like item 1, 2, 3, right? So you don't really say I mean you don't state your user ID in the prompt.
Yeah.
So in the prompt you also say item 1, item 10, item 5, and then
Yeah, so I think it's also explain that what you give in the input to get the output, and they are not the same. It's like what you put already for the training test, for the training price.
it's just
Anyway, I think we should skip it.
sorry for such a bad question.
Furthermore, they have another setting that whether we can use the negative preference to improve the performance of recommended system task. That if you have some information about user will dislike the following movie 1 to 5. So they will also list the type movie as the description list. So we see the input of fattening styles. We how the performance is improved. And in this case, they will. In this case, they show the performance of the application of language model in recommended system task, and they will have some baseline, like if they use choose a random movie to suggest from user, or choose the popular item to suggest user. This is the two simple baselines. And after that, they will also apply some conventional methods of recommended system in this data. We have some twisted measure rating metric factorization, PPR, or KNN, etc. And after that, the last 4 rows is the way they apply large language model in recommended system. We can see that we can see that if we only if the accuracy of conventional methods is quite good. But if we apply the large language model in recommender system, it can be obtain a more good result on unseen dataset, on unseen movie. Yes, I think the results are only comparative as the name of the paper. Yes, it's not to
empirical study.
empirical. Yes, yeah, I think the result is not too impressive. And if we compare the two kinds of testing that we already use information about this like item or the description about like item of each user, and we use both of them, but the result is not, it also is not too different. But in general, the result in testing of both we using both kind of information is better than the 3-2-1 remain to other.
I can see that the experimental result from the language model they use is slightly different from the original language model, like the BM55 version, but compared with the item base, it's like not very quite impressive.
Yes, it's not impressive, and it's as in the name paper they also say that the application of large language models is also comparative. It's not really impressive.
Or the negative, you give them a list item, you dislike, then the performance improves.
Yes,
As well. I don't know, it's why somehow it's even worse. So there's some,
it's more worse.
I think, yeah, there's some kind of confusion. Because I'm right? If you say that you dislike this 5 item, right, then there should be less more. Yeah, it should
Yes,
be easier than zero.
yes, it's
Zero.
it's more rich in data source, but the performance is not improved at all. Yeah, that's the result obtained of the authors.
Structure.
Yes,
They just want
and yes, and after this paper, they have some contributions that they designed an experiment to compare natural based recommender system and to item-based recommender system, and they also collect a small data set. And they also experiment with different patterning styles. Yes, that's all my presentation. Yes, thank you for listening. Do you have any questions? Em Huy có góp ý hay câu hỏi gì không?
Không em.
Thế hỏi lại đi.
Em Huy có câu hỏi hay góp ý gì không ạ?
Không có.
Tắt cái mic này. Vâng. Thế cho mình kết thúc meeting ở đây.
Ok.
Mình còn một cái